Afternoon all, it's Postbag, and because I'm not a great believer in delayed gratification, it's the big one first, and this is from Amazon.co.uk. So this is a mini multifunction jump starter, car emergency start the car immediately even with flat batteries, bright lighting 60 hours, detonation flash, blah blah blah, a 20th of the size of the old jump starter. Wow. And so inside this box there is a bag, and inside the bag there's all this stuff. Now this is branded Inori, and this was sent to me by Inori for review. So when they say a 20th of the size of a regular car jump starter, well, yeah, that's about right. Here's a regular lead acid car jump starter, and here's the little Inori lithium battery pack. So what this is a power bank essentially. It's got lithium batteries inside it, and it has a range of input and output sockets, including 5-volt USB, 12 volts at 2.0 amps. There are markings on the plastic here, but they're quite hard to see. Now this one is the input, 12 volts to 20 volts at 1 amp. The USB is marked 5 volts at 2.1 amps. This is a bar graph scale to see how full the battery is. And then this one is an output of 19 volts at 4 amps. But what's unique about this power bank is that under this flap you have a very, very high current output. Now this is meant to be 12 volts at around 200 amps. Yep, that's right, 200 amps. And in the bag of bits that comes with it, where you get all these cables, one of them is this pair of large crocodile clips, and they're designed to attach to your car battery, and you can start your car. Now, of course, I was intrigued by this, and when I do the full review of this power bank, I will indeed attempt to start my car using these connectors. I'm going to put a completely dead battery in the car and see if it'll start with this. Now let's just have a look at this jump starter lead. Big croc clips, certainly think they could handle 200 amps. The cables look like they're silicon coated, and they are 10 AWG, so I don't suppose it says the current on here. No, just 10 AWG. Now there's a big sort of square box here. I could take this wrapping off when I do the review, because it'd be fairly easy to put a piece of heat shrink back on there. And then there's this connector. Now that says BAT in there, and that says it's an EC5, and it has plus and minus on it. And I was just comparing it with the XT60 connectors that you get on radio control battery packs. And this is, I think the 60 means 60 amps. And if you compare the sizes, you can see how, if this is 60 amps, this could well be 200 amps. They're really big. So let's switch this on, and we've got 4 of the 5 lights. And I just wanted to check the 5-volt output. So we're reading 5.14 volts, so that looks fine. Now it says don't attempt to start your car with this if it's reading any less than 3 of these lights. I don't think I'd want to attempt to start my car if it was reading any less than 5. In actual fact, it auto shuts off, as you can see. And then the 19 volt, which is actually over here, the 19 volt output is of course for laptops. And I do have an old XP laptop, which the power supply says 18.5, but it's near enough. And we can see whether this can power my old laptop. Now I've just poked my meter probes into these 200 amp outputs because I was interested in the battery voltage. I'm trying to guess how many, it's got to be lithium, but how many lithium cells are in here. And I'm getting 11.77 volts, so I'm now thinking 3. I was thinking 4, and that this would be about 14 volts. But what's 3 times 3.7? Nominally that would be 11.1. well charged, it is going to be a bit higher than that. So I'm thinking it's a 3-cell pack in there. Maybe it's even a radio controlled model battery pack. Who knows? So here's the item on Amazon.co.uk, and it is the Inori 1200 mAh portable car jump starter, emergency, auto, and all the rest of that stuff. And it's £52.99, free delivery in the UK. Okay, now this one looks like it's from Banggood. They tend to use this grey plastic packaging. Let's open this up. Now this is a small lithium battery pack to replace the one in my wearable project. So here's the wearable device, and the original position of the LiPo was velcroed onto the back of the charger board, but the next idea was to tip that up like that to create a fairly thin sandwich, bring the OLED display up round the back and sandwich it all in there. But the LiPo doesn't last very long. This is a 240 mAh, and I wanted to find something that was not much bigger but a lot thicker. Now that certainly worked out. This is twice as thick as the 240, and this is a 600 mAh, but it is rather a lot larger, and so it's going to be difficult to house up here on top of that charger board without it looking a bit silly. So I'm not sure whether this is going to be the final LiPo pack, but it's certainly a nice pack. It comes with this connector. Now that connector looks like it would fit in the port on the LiPo fuel gauge, but unfortunately that's no longer a battery input, that's now a power output, so that's not going to work either. So I'm not 100% sure how to use this at the moment, but I thought I'd get it in because it just looked like it was about the right size and shape. Now I've just noticed that this has a black plastic cover running over the top, and actually you can see fresh air inside there, so I'm not quite sure what's in there. These ears, or these silver bits sticking up, are just the ears of the LiPo pack, so it's possible that the LiPo pack only extends up to this part, and I'm just wondering whether perhaps inside there's a battery protection PCB. I think I'm going to have to cut this bit off and have a look at that to see whether I could shrink this battery down to the size of the silver part here. Now I've removed all the tape and this black plastic cap, and there is indeed a PCB in there. You can just see a chip on the end there, so it does look like that's a battery protection board, so that could possibly be removed if I'm happy soldering or desoldering these tags here. Now they come up out of the sort of squeezed end of the pack on these two silver tabs, so I could, if I'm feeling brave, attach those directly to my charger board, and then I lose this section which was covered with this black cap, and things are slightly smaller. I'll have to have a think about that. So this is the item on Banggood, and it's called a Great Wall 2112 RC car part. So it's intended for some sort of radio controlled car called a Great Wall, whatever that is. 3.7 volts, 600 mAh, and that's $5.99, free shipping to the UK. And I just thought I'd look to see what it was. This is the Great Wall 2112 radio controlled car, $38.99. Now this one is from the UK, and it is a knob. Now you're probably wondering, how can I justify putting a plastic pointer knob on my Postbag video? Well, if you remember the 20 position rotary switch, in part 1 of that video I had a lot of feedback and comments about libraries that existed to read this thing, and techniques for debouncing it and all that sort of stuff. And I wanted a foolproof way of seeing whether those techniques actually work. And here's my plan. So, piece of cardboard, rotary switch is on the back, the 20 positions marked on there, and then you'd put it on position 1, reset the software to 1, and then wind this thing forwards, backwards, also wind it sort of halfway between 2 positions, go fast, go slow, try all manner of techniques to try and get the software to lose synchronization with the actual position of the knob, and if it does, then it isn't a foolproof technique for reading this switch. If you can do anything with this knob and the software can keep synchronized with the position of it, then you know that the software and the debounce techniques are good. So certainly expect to see the switch and the knob and this piece of cardboard in part 2 of the video on this rotary switch, where I'm going to try actual techniques for reading it using polling, interrupts, and possibly some of the sequence matching techniques that some of the libraries use. And so this little lot is today's postbag.